Continuing our discussion of alternative concentration units, let's take a look at mole fraction here. Mole fraction is an interesting one because we won't see it used often, but when it is used, it's going to be used in some really kind of unique ways to describe properties that we have described before but really never been able to put numbers to. So mole fraction is set up like this. It is usually given by this funny looking X. It's actually the Greek letter chi. Um, and it's always given a subscript denotation here. So the letter A here represents some component of the solution. It could be the solute, it could be the solvent, it really can be anything in the solution. But the mole fraction of A tells us how many moles of A are in that solution divided by the total of all of the number of moles of all the components in the solution. And so where this is really important is we have to make sure we know what A is and that we calculate for A. We can't just assume it's the solute because all of our other concentrations have been solute based. In some cases, as we're going to talk about in Monday's or the next series of videos, is going to be about solutions where the solvent is really the thing under study because it's the thing that evaporates. So before we move on into colligative properties, it's important for us to look at, can we do all of the calculations that we need to do? And so for that, here's kind of an example problem of all the different types of calculations, all the different types of concentrations that are possible. And so in this scenario, I've got 75 grams of acetic acid being dissolved in 245 grams of water to form 309 milliliters of solution. So let's actually break this out into a larger space to show what it is that we have to do. All right, so here we are in the whiteboard space, and I'm going to show you, this is the same problem. Find the molarity, the molality, the mole fraction of the water, the mass percent of the acetic acid, and the density for the solution. Now, in multi-factor problems like this, where I've got many things to find with very limited data, sometimes it just helps to kind of write out what it is that I need to do. And so I know that molarity is equal to moles of acetic acid over liters of solution. I know that molality is moles of acetic acid divided by kilograms of water. I know that mole fraction is going to be moles of water divided by total moles. I know that mass percent is going to be the mass of acetic acid divided by total mass times 100%. And I know that density is going to be mass of solution divided by milliliters of solution. So before I get into calculating any of these individually, it would make sense to just kind of collectively find all of the information that I need. And so I need moles of acetic acid. So moles of acetic acid can be found this way. I need 75.0 grams of acetic acid. And I'm going to convert it. Molar mass of acetic acid, 1.01 for hydrogen plus 12.01 times 2 for carbon plus 1.01 times 3 for the other hydrogens plus 2 times 16 for the oxygens, 60.06 grams. For every mole. which will give me 75.0 divided by 60.06, 1.25 moles of acetic acid. Now I also know that I'm going to need moles of water for mole fraction, so I'm going to take care of that one here as well. Moles of water. I have 245.0 grams of water. Molar mass of water is 18.02. And so 245 divided by 18.02 is, to four significant figures, 13.60 moles of water. Total moles would be 1.25 moles of acetic acid and 13.60 moles of water, which would be 14.85 moles total. Let's see, total mass would be 75 grams of acetic acid plus 245 grams of water. 75 plus 245. Try that again. Is 320. And so I've done all of this legwork. Now the reason why I've done all of the legwork is so that we can very quickly now solve all of the problems. So switch up here to a black. So for molarity is equal to our moles of acetic acid, 1.25 moles of acetic acid, divided by liters of solution. 309 milliliters is 0.309 liters of solution. And so solving that one, 1.25 divided by 0.309 is 4.05 molar. Molality is similar, 1.25 moles of acetic acid divided by kilograms of water, so 0.2450 kilograms of water. And so 1.25 divided by 0.245, 5.10 molal acetic acid. For mole fraction of water, I need the moles of water, 13.60, and the total number of moles of water, 14.85. 13.6 divided by 14.85 is 0.9158. Mole fraction, since moles is the unit in the numerator and the denominator, it's just going to be a decimal number. There is nothing else with it. For mass percent, we need the mass of the acetic acid divided by the total mass multiplied by 100%. $75 divided by 320, and then multiplied by 100 would give 23.4%. And then finally, the density of the solution. The density of the solution is its mass divided by its volume. The mass of the solution in total was 320.0 grams. The volume of the solution was 309 milliliters. And so 320 divided by 309, 1.04 grams per milliliter is our density. So this is probably as complicated as a solution problem can get, but you can see that with very limited data, we can solve a lot of questions about concentration. All we need to know is how much by mass each component makes and what the total volume is, and we can solve and figure out all of these different concentration values. So the subject of our next lecture is going to be how do we use these concentration values to actually explain physical properties. And so the physical property we're going to look at first is the physical property of vapor pressure, and then its relationship to boiling points and freezing points, all through a really fascinating relationship known as Raoult's law. So until that time, have a good day.